Okay, so here's where we are. This is our first question for today. So the whole goal behind this is for you to be able to identify variables. So someone talked to me about when we're identifying variables, we know that the variable is the what? The variable is the, I want everyone to close their Chromebooks. You're not having full attention. The variable is the what? We did this when we did linear equations, not systems. The variable is always the question. The variable is always the question. So if I read this, it says money problem. A store sold 28 pairs of cross trainer shoes for a total of $2,220. Style A sold for $70 per pair and style B sold for $90. The question is, how many of each style were sold? How many styles do we have? We have 2 styles, so that means we need 2 variables. So I always use X and Y because it just fits with my brain. So I'm going to say let X equal, and that's what that little X is for. So X is going to represent style A. X is going to represent style A. Maybe. Okay. So style A. And it's the number that I sell, number of shoes. So for Y, so Y is going to represent style B, the number of style B. So now we have to come up with 2 equations for our system. We have to come up with 2 equations. And here's typically how they work. The first thing that, like the first equation that we write is usually the number of items. Not always, but usually it's the number of items. And then it's typically representing, the next one typically represents the total cost. So when we think about the number of items, if X is the number of style A shoes, plus Y, which is the number of style B shoes, how many pairs of shoes did we sell? What does it say up there? We sold 28. X plus Y is 28. So the next equation that we write has to deal with money. Okay, the next equation that we write has to deal with money. So how much does it cost for a style A trainer? So 70 times however many style A trainers we sold, plus how much does it cost for a style B trainer? Plus 90 times however many style B trainers we sold, cost a total of how much money? There you go. Now I know that you have a graph to the right. I would never, ever solve by graphing unless that was the only option, ever. I wouldn't. Okay. So I would use, just because these numbers down here are quite big and I wouldn't want to have to multiply anything by 70 or 90, I think that substitution would probably be the best bet. What do you guys think? Okay. So if I want to solve by substitution, I'm going to write that here, substitution. What do I need to do first? So first, I need to solve. Are we going to solve for X or solve for Y? What do you want to solve for, Rylan? So you're going to get X all by itself? Okay. So solve for X in the first equation. So here's what that looks like. X plus Y equals 28. If I subtract Y from both sides, what does X equal? X equals 28 minus Y, right? Yeah. Okay, so I've solved for X. So now I'm going to take the second equation. So now I'm going to use my second equation. 70X plus 90Y equals $2,220. But I'm actually going to take this expression, 28 minus y, and plug it in for x. I hope some of you guys have calculators. So let's see, that means 70 times 28 minus y plus 90y equals $2,220. All right, so what is 70 times 28? So 1,960, and 70 times negative y is negative 70y. That's all right. You're on page. I don't know where my filled out note packet is, Braden. Give me a hot second. No, that's all right. That's okay. There you are. You can look off mine.
Appreciate it.
Do you need a pen or something to write with?
No, ma'am.
Okay, perfect. So plus 90y, sorry, that's where I left off, equals 2,220. So I'm going to combine like terms, and I'm going to subtract 1,960 from both sides. So minus 1,960, minus 1,960, and I'm going to combine these two. Okay. So when I do that, what is a negative 70 plus a positive 90? So 20y equals, let's see, 200, let's see, 2,000, so 220, 260. Is that what you guys got?
Yeah.
So 20y equals 260. Divide both sides by 20, and I find out that y equals 13. So I sold 13 type B shoes, 13 style B shoes. Well, how many style A shoes did I sell? Take that first equation that you wrote, x plus y, number of shoes we sold, has to equal 28. Yeah, and if I sold 13 style B shoes, that means that I sold 15 style A shoes. So this is a word problem, and with a word problem, you need to give a word answer. So I'm just going to say they sold 15 style A and 13 style B shoes. So I wouldn't graph it. I wouldn't use a graph to solve this unless it specifically said solved by graphing. And then if it said solved by graphing, I would go to what app? Yeah, I would go to Desmos. I would absolutely not solve this any other way other than Desmos. Because, I mean, if it wanted a graph, just because 70 doesn't go into 220 evenly, and neither does 90. So you're going to end up with like decimals, right? It'd be horrible to try and graph that accurately. It'd be absolutely horrible to try and graph that accurately. Almost impossible. Okay. So they sold 15 style A and 13 style B shoes. You guys feel okay with that one? Does anyone still need me to leave that up there? You good with it, Braden? You sure? Okay. I'm going to leave it there for a second. I didn't show all my work on my clothing notes.
Oh, now I really don't have room for it.
You don't have room for it?
I could try.
Andres, pick your head up, please. Is it okay if I talk while you write? So the next problem that we're going to do is a mixture problem. And mixture problems seem to be the hardest type of problems. And usually they give you, like I will tell you that looking at the EOC from 2 or 3 years ago, they typically give you a mixture problem that has something to do with coffee or some kind of like candy variety mixture or like nuts and chocolate. Like I don't know why, that's just kind of how they always are. Sometimes they'll give you a chemical mixture that's like 15% alcohol, but rarely, because we don't work with percentages a lot. That's more of like a chemistry kind of question. So I want to talk about a mixture problem. So the mixture problem says a coffee merchant has two types of coffee beans. One sells for $9 a pound, and the other one sells for $15 a pound. The beans are going to be mixed to provide 100 pounds of this blend, and they're going to sell this blend at $13.50 per pound. How much of each type of coffee bean be used to form this 100 pounds of mixture? How much of each type should be used to form this mixture of 100 pounds? So let's just think about that for a second. Braden, are you good for me to unfreeze and go? Okay, perfect. So let's see. I have two types. I have the $9 type and I have the $15 type. So my variables, when I define my variables, I'm going to say let X equal the pounds of $9 beans, and Y is the pounds of $15 beans. Okay. So how many total pounds of coffee do I want? I need 100 pounds. That means the first one, the number of items, X plus Y, has to equal 15. Oh, sorry, not 15, 100. Sorry. X plus Y has to equal 100. So I need 100 pounds. The next one is going to have to do with money, right? The next one has to do with money. So how much does the $9 bag cost per pound? Well, they cost $9 a pound, right? So 9X. And then the $15 beans cost $15 per pound. And how much do I want that to equal? What am I selling my beans for? $13.50. And how many pounds am I selling altogether? Of 100. So a mixture problem is different because the first one talks about the number of items. X plus Y has to equal 100 pounds. The second one, when we talk about the money, we're selling 100 pounds at $13.50. So you have to multiply those two to get that total. Okay. So let's just rewrite that second equation. What is 1350 times 100? Yes, yes, yes. When you multiply by 100, you just move the decimal 2 places. So it equals 1,350. So now I have the two equations that I need. So do you want to solve for X or solve for Y? Solve for X. So we're going to rewrite this equation. We're going to solve for X. Okay. So if I subtract Y from both sides, I have X equals 100 minus Y. Does everybody see what I did there? I just subtracted Y from both sides. I'm going to take my second equation, 9X plus 15Y equals 1,350. And I'm going to plug in this expression right here for X. I'm going to just substitute that in. So I'm going to rewrite that. So let's see, that looks like, I have to make these smaller. So that looks like 9 times 100 minus Y plus 15Y equals 1,350. Well, 9 times 100 is 900. 9 times negative y is negative 9y plus 15y equals 1,350. So now what are we going to do? Combine like terms, okay? So I'm going to group these two together. When I combine those two things together, let's see, negative 9 and a positive 15 give me, so 900 plus 6y equals 1,350. Okay, and what is 1350 minus 900, Rylan? 450. 450 divided by 6 is? Someone said 55 or 65? Oh, 75. Thank you. So that means that the mixture that we make is going to have 75 pounds of the expensive bean. 75 pounds of the expensive bean. How many pounds are we selling altogether? 100. If we're selling 100 pounds and we know that we're going to use 75 pounds of the expensive bean, how many pounds are we going to use of the non-expensive bean? 25. How did we do that? We did x equals 100 minus y. X equals 100 minus 75. I mean, we didn't write it out. We just kind of did it in our brain, right? So this is a word problem, so I need to give a word statement. So I'm going to say they made the mixture with 25 pounds of $9 beans and 75 pounds of $15 beans. Do you guys feel okay with that? Raise your hand if you still need me to leave that up there. Okay. 2 more, and then we're going to cut these and put them in our journal. So this is the typical type of system question that you're going to have. This is a typical type of system question. Find the value of 2 numbers if their sum is 12 and their difference is 8. Their sum is 12 and their difference is 8. I know that you guys can probably just think about that for 30 seconds or less and probably come up with those 2 numbers. We still have to define our variables. So I'm going to let x equal the smaller number because one's got to be smaller and one's got to be larger, right? So x is going to be the smaller number. I don't know why it's not writing. I'm shutting that off. I'm just shutting the OneNote down for a second. So x is the smaller number. Define your variables for me. X is going to be the smaller number and y is going to be the larger number. Just write that down for me. X is the smaller number and y is the larger number, please. So it says the sum, x plus y, is 12. So the only tricky part is when you do the difference one, right? Their difference is 8. That's a positive number. That means that I have to take the larger number minus the smaller, right? So y minus x equals 8. Well, the first thing that I'm going to do is I'm going to rewrite this second equation so it's in standard form. I'm going to just rewrite this. So I'm really going to write it as negative x plus y equals 8. And the first equation, I'm not changing at all. Positive x plus y equals 12. And what method can I use to solve these? Yeah, elimination. I'm just going to add these two equations together. So a positive 1x and a negative 1x give me 0. 1y plus 1y, well, that's 2y, equals 12 plus 8 is 20. Divide both sides by 2. Yeah, y equals 10. So go back to your sum. If y equals 10, what does x equal? Yeah. So one number is 2, and the other number is 10. One number is 2 and the other number is 10. Those are the types of problems that you'll see more often than not. We have one more, and then we'll cut them apart, put them in our journals, and then I'm going to keep your journals to grade. Grade over the weekend. No, actually, I'm grading them today before I leave. Are we ready to go to the next one, or do we still need this up? Raise your hand if you need more time. Okay. Ma'am.
You should let us try doing this one by ourselves.
You can. That'll be perfect. You guys can try this one by yourself. A farmhouse shelters 17 animals. Some are cows and some are geese. Altogether, there are 56 legs. 56 legs. How many of each animal are there? I'm running a video, so you guys can think it out, but I need someone to talk it out with me, just so we can get the video done. So who's defining the variables for me? Yeah, number of cows, number of geese. I love that. Okay. Someone different. What's the first equation going to be? Yep, number of animals, x, number of cows plus y, number of geese equals 17. The next equation is going to have to do with their legs. Go ahead, Carter. Yeah. Providing that like none of the geese got caught in some kind of machinery or the cow didn't like lose a leg. We always have to say that, right? Okay, so I still think elimination is going to be the quickest. What do you want to multiply the top equation by to eliminate one of those numbers? One of those variables. -2. I'm going to go with the -2 to get rid of the y's. So we have smaller numbers. So I'm going to multiply the top equation by -2, and I'm going to multiply the bottom equation by 1. -2 times x is -2x. -2 times y is -2y. -2 times 17 is -34. And then the bottom equation doesn't change because I'm multiplying by 1. 4x plus 2y equals 56. So when I add my two equations together, -2x and a positive 4x give me 2x. -2y, positive 2y cancel out. negative 34 and positive 56 give me positive 22. So how many cows do I have? I have 11 cows. If I have 11 cows, how many geese do I have, Braden? 6. Good job. So let's say that. The farmer has, or the farm has, I don't know. The farm has 11 cows and 6 geese. That is it. That's how we do it.